Welcome in. On this episode of Renewable Energy Reality Check, we discuss extreme weather, surging energy demand, and the energy-intense reshoring of American manufacturing. The year 2026 represents a pivotal moment for the advancement of global electrification, especially in the United States, exposing the wear and tear of outdated systems and the inevitable upgrades set to transform the world. The first quarter of 2026 showcased the grid's susceptibility to increasingly frequent and severe weather events. These incidents, often referred to as gray rhinos due to their predictability and high impact, are no longer rare occurrences. Here are some key examples, two from here in the US and one key event from around the world. Winter Storm Fern, January 2026. This storm caused over 1.2 million outages across the US, with widespread damage including snapped power lines and frozen substations. Mississippi severe weather, March 2026, resulting in 48,000 outages. This event saw distribution pole failures and transformer blowouts. Australian heat wave, January 2026. Extreme heat led to grid strain, sagging transmission lines, and the failure of thermal equipment, further exacerbated by wildfires. These events collectively cost $5.4 billion in emergency repairs in 2026, a stark reminder of the inefficiency of reactive maintenance. The takeaway is clear. Climate-driven disruptions are predictable and demand proactive measures to harden and fortifying the grid against future threats. While extreme weather is a significant challenge, three additional factors are driving the urgent need for grid upgrades. Artificial intelligence is reinventing industries, but its energy requirements are staggering. By 2026, global data center electricity consumption is projected to reach between 340 and 380 terawatt hours, with AI workloads accounting for nearly half of this growth. A single AI facility now requires between 70 and 100 megawatts of power, equivalent to the energy needs of a small city. For example, in Northern Virginia, the demand from AI data centers has created a 5 gigawatt shortfall. Utilities like Dominion Energy are racing to invest over $1 billion in substation and transmission upgrades to keep up. Without such investments, the AI revolution could face significant energy bottlenecks, slowing its progress. The strategic push to bring semiconductor and EV battery production back to the US has introduced massive, continuous industrial loads to the grid. Semiconductor fabs, such as TSMC in Arizona and Intel in Ohio, require between 150 and 250 megawatts of stable, high-quality power to operate effectively. The stakes are intensifying. A single 1-minute outage at a semiconductor fab can result in millions of dollars in lost wafers and recalibration costs. This industrial resurgence, critical for economic and national security, hinges on a reliable and modernized grid. The grid's physical infrastructure is rapidly approaching the end of its useful life. Over 40% of high-voltage transformers are more than 40 years old, exceeding their 25-year design life. Similarly, nearly 70% of U.S. transmission lines are over 25 years old, leading to inefficiencies like line losses and congestion. The aging infrastructure is increasingly ill-suited to handle the demands of the 21st century, making upgrades essential. To properly address these challenges, the focus is shifting to smart resilience, an approach that combines fortification, intelligence, and flexibility. Here's how. Investments in composite poles, undergrounding, and fire-resistant corridors are planned, with $36 billion allocated for 2026 to 2030. Advanced technologies like AI-driven load forecasting and dynamic line rating, DLR, are being deployed. Phasor measurement units, PMUS, are also being installed for real-time monitoring, improving the grid's responsiveness. Utility-scale battery storage is expanding, with more than 100 gigawatts planned globally. Virtual power plants, VPPs, are being integrated to enhance grid flexibility and reliability. These measures aim to transition the grid from a reactive, centralized system to a proactive, decentralized, and intelligent infrastructure capable of meeting modern demands. The data from 2026 underscores that the electric grid is the foundational layer upon which all modern advancements depend. Whether it's enabling the AI revolution, supporting reshored manufacturing, or ensuring public safety during extreme weather events, the grid is at the center of it all. The final outcome is clear. Modernization to a decentralized, intelligent, and hardened grid is the most critical capital project of the decade. Without accelerated upgrades, the consequences will be severe, more frequent outages, higher costs, and a cap on the growth potential of key industries. The electric grid is no longer just infrastructure. It's a strategic asset that underpins national security, economic growth, and technological leadership. The time to act is now. That's it for this episode of Renewable Energy Reality Check. If you haven't already, comment, and subscribe. Always remember to take care of yourself and take care of one another.